learning how to solve simultaneous equations using another method. Okay, your elimination method compared to the graphical method that we did just now. Okay, both variables have the same sign. Okay, you take the first equation minus the second equation. If both variables have different signs, okay, you take one equation plus the other. Okay, you can always form the third and fourth equation if they do not have the same variables. Okay, using your LCM, your lowest common multiple. Okay, so I'll touch onto this later on further down the notes. Okay, so if we look at the example that we have here, okay, your first example, you have 2x plus 3y equals 15 labeled as equation 1, 4x minus 3y equals to 3 labeled as equation 2. So if you have seen as what highlighted in the notes itself, okay, both have the variable of 3y, or the coefficient of the variable 3y. Okay, so in this scenario, okay, before you even start, always make sure that your x and y are on the left hand side and your constant is on the right hand side. Okay, then we move on to eliminate one variable, okay, by taking the subtraction of one of the other, or we add the two together. Okay, so based on what you see or I mentioned just now, okay, you have both equations with a 3y. So, and they are of opposite signs. One is a minus, one is a plus. Which is why we will add the two equations together, which is 1 plus 2. Okay, then you take note, okay, always adding the brackets here first. Okay, this is to prevent careless mistakes. So, after you have simplified your equations on both sides, okay, you realize whatever you move on the left hand side, okay, the equation 1, 2x plus 3y on the left hand side, 4x minus 3y on the left hand side as well. Okay, same thing on the right hand side, okay, 1 plus 2, right? So 15 plus 3, okay, that's how you get the 18. Okay, so simplify and you get 6x equals to 18. Okay, then you solve for x, you get x equals to 3. Once you are done with that, okay, you substitute x equals to 3 into either of the equations, okay, whichever you prefer. Okay, but normally try and work with those that have smaller coefficients. Okay, so you sub into equation 1 because equation 1 only has 2x compared to 4x in equation 2. Okay, so sub your value of x inside. Okay, you solve for y, you get y equals to 3. Then you end with a final statement where therefore x equals to 3 and y equals to 3. Okay, that's a very simple example of your elimination method. So now we look at the example that we have below. Okay, for part A. Okay, solve for these two simultaneous equations. Okay, so if you realize, okay, these are not arranged in the correct order for you. Okay, all your variables on the one on left hand side and all your constants on the right hand side. Okay, so before we start, what we're going to do is we're going to rearrange these variables. Okay, so for the first one, okay, I'm going to shift my 2.4y over. So I have 3x minus 2.4y equals to 18. This will be equation 1. Okay, equation 2. Okay, it's already given you to 4 plus 3x plus 0.4y equals 0. So I'll just shift over the 4. So I'll write 3x plus 0.4y equals to minus 4. Okay, take note, it's a minus 4. Okay, then label equations 1 as 2 as well. So now if you look at the variables, okay, both of them have 3x and they are of the same sign. So same sign, you take one equation minus the other. So I have 1 minus equation 2. Okay, then write your brackets, sub it in. Okay, this is what you should end up with. Okay, so take note, minus 4. Okay, so just put a bracket on the minus 4 if you need to. Okay, so your x on the left hand side will have been cancelled out already. Okay, you end up with minus 2.8y equals to 22. Okay, divide the minus 2.8 over. Okay, leave it in your proper fraction form. Okay, 7/6 over 7. Okay, sorry, negative 7/6 over 7. Okay, so once you have gotten this y value, Okay, sub it into equation 1 or 2 to find your value of x. Okay, so I'm going to write it at the side here. Okay, sub y equals to negative 6 over 7 into 1. Okay, so 3x minus 2.4 times minus 6 over 7 equals to 18. Okay, you end up with 3x equals to okay, you end up with 2 over 7. Okay, divide the x over, you end up with 2 over 21. Okay, so this will be your two values of x and y. Okay, then write your final statement. Therefore, x equals to 2 over 21, comma y equals to minus 6 over 7. Okay, that's it. Okay, so in this scenario, your values are a bit in the decimal form. Okay, if you key your calculator, you might get a decimal form. Okay, but if you are able to, like in this scenario, leave it in the proper fraction form. Okay, please try not to round up if you can. Okay, next we move on. Okay, now, okay, similarly you work with your elimination method. Okay, but this is the scenario where both coefficients are different. Okay, for the equation 1, your x is 2, equation 2 is 3x. Okay, 3y, 4y, both are different, which means before I even take one minus the other, I need to manipulate both. Okay, so in this scenario, they work from the x. Okay, so the LCM or lowest common multiple for 2 and 3, okay, is your 6. Okay, so what they did was they formed equation 3 and 4 by multiplying equation 1 times 3 and equation 2 times 2. Okay, that's how they get equation 3 and equation 4. So after you have formed equation 3 and 4, okay, both of them have 6x and they are of the same sign. So you take one minus the other. That is why you have equation 3 minus equation 4. Okay, same thing, work out and simplify. You solve for y. Okay, then next, okay, same thing, you sub your y value. Okay, equals to 51 into, okay, you have 4 equations in this scenario. Okay, but you should never sub back your value into equation 3 and 4. Okay, always sub it back into 1 and 2, which are the original equations. Okay, because you want to work with as small a number as possible. Okay, so sub it in. Okay, you solve your value. Okay, you'll get x equals to minus 69. Okay, so this is same thing, the same concept of elimination method, just that the coefficients are different. Okay, so there is one additional step of forming equation 3 and 4.